Chapter 4-8, complex numbers. The complex number system, it exists only to take the square root of a negative number. That is the whole point of a complex number system. Do you remember when we did our discriminant, b squared minus 4ac? If it was less than 0, you had no real roots, right? Now, you will have real roots. I shouldn't say real, but imaginary, okay? Now, the form of a complex number is in the form of a equals or a plus or minus bi. A is the real number, b is the imaginary number, okay? Now, the square root of -9. Does there exist a number multiplied by itself that gives you -9? What's 3 times 3? Not -9. What's -3 times -3? +9. Can I have any other options? I can have 3 times -3, but are those the same numbers? No, they're very different, aren't they? So what they did is they pulled it apart and made it 9 times -1. And they said that I squared is equal to -1. They assigned the letter I and squared it and said that was equal to -1. So every time you see a -1, what can you legally substitute in for it? I squared. So that's what they did. The square root of 9 times I squared. Did we see that? What is the square root of 9? 3. And what is the square root of I squared? I. The power and the root are exactly the same, so therefore they cancel. They cancel out. What about this? $18 is not a perfect square, but can I pull it apart and make it into something else? I can. I can say that that's 18 times -1. But does 18 have perfect squares? It's not a perfect square, but does it have perfect square factors? 9 times 2. So 18 becomes the square root of 9 times the square root of 2. And what does -1 turn into? I squared. What is the square root of 9? Can I do anything with the square root of 2? No. How about the square root of I squared? That comes out as an I. So now what I have is 3i times the square root of 2. 3i times the square root of 2. Yes? Okay, what do I do? Looking for perfect square factors of 48. Give me two numbers multiplied together give you 48. 6 and 8. What is 6? 2 times 3. What is 8? 4 times 2. I have a 4, and then the 2 and the 2 make 4, right? So what's 4 times 4? So you're telling me that 16 times 3 is what I have. And what is -1? I squared. Now what is the square root of 16? What is the square root of 3? Can't do it. What is the square root of I squared? So what does that give you? Very good. We getting it? Great, because that was just like the intro. Sorry. It's much easier after this. That's the hard stuff that they kind of think, oh, well, you guys might know that. So I'm just going to throw this in there too. Next, how do I graph a complex number? Now let's graph 3 minus 4i. Now, this is what your xy plane normally looks like, correct? Now, on the xy plane, instead of being in the xy plane, you're going to be on the real imaginary plane, okay? Your x-coordinate, your x-axis now turns into be your real axis, and then your y-axis turns into be your imaginary axis. You had a very good guess. It's positive 3 is my real number, so on my real axis, I'm going to go to the right 3 units. Why? Because it's positive. And then my imaginary axis is going to be up and down, so I'm going to go to the right 3, and then I'm going to go down 4. And this is my point, 3 minus 4i. Do we see that? Puts it on the imaginary axis. Okay. How about negative 7 plus 9i? Brandon? 2, 4, 6, 7 units. 2, 4, 6, 8, 9. That is going to be the point. Negative 7 plus 9i. Do we all understand how to graph it on a coordinate plane now? Yes or no? Does that make sense? Okay, great. Because now we're going to add two complex numbers together. What's that? Well, that would be logical, right? You're adding two complex numbers together, so wouldn't it make sense that you'd add the real number together with the imaginary number? Now, do I need the parentheses whenever I'm adding like terms? No. I can drop the parentheses. And I can simply look for them. What is 9 plus 23? 32. And what is 7i minus 21i? Minus 14i. And you're done. Don't have to graph it unless it says. It would be right 32 and down 14. Okay? Now we added. Now what do you think we're going to do? Subtract. Okay? Can anybody tell me what we should do? Do we drop the parentheses? Why do we not? Because you're subtracting off not just one term, but two terms, right? So I can drop the parentheses around the first complex number, but the second complex number I have to distribute the negative to give you positive 26i. Oh, why did I write 26? I took 2 times 13. I don't have any idea why. I just did. My apologies. Where's my marbles? What is 6 minus 12? Negative 6. What is 9i minus plus 13i? Plus 22i. Notice how I'm always writing it as a plus bi. A being the real number, bi being the imaginary. Now, I'm multiplying by an imaginary number. So what do I do? Distribute. 3i times 4, 12i. 3i times 7i. And what is I squared equal to? -1, so I plug in -1 for I squared. Oopsie. To give you 12i plus 21. Now, is that the form that I like it to be in? I like it to be in a plus bi form, so this is 21 plus 12i. Yes? I don't know. How are your notes looking? Pretty skimpy? Okay, now what do I do? Now I'm multiplying two complex numbers together. Anyone? What should I do? FOIL. FOIL. Good try, though. 4 times 3 is 12. 4 times -7 is -28i. 3i times 3 is 9i. And 3i minus times -7i is going to be -21i squared. What do you think we should do? Combine like terms and do what? And I squared is -1. So 12. What is -28i and 9i? Minus 21i. Minus 21i squared becomes -1. Do we see that? A negative times a negative is a positive. And what is 21 plus 12? Minus 21i. Do we see that? -28i plus 9i gives you, crud. I think I'm going to have to re-record next period. Thanks. Sorry. When the signs are the same, it's positive, and the signs are not the same, it's negative. Do this one. Okay, what do I do? -3 times 1 is -3, minus 12i, minus 15i, minus 60i squared. Yes? Do I have any like terms? -3, -12i, and -15i gives you -27i. And what is I squared equal to? So this is going to be minus 60 times -1. So that's -3 minus 27i plus 60 to give you 57 minus 27i. How many of you got that? Okay, dividing by an imaginary number. Here's the kicker. You cannot divide by an imaginary number. You can, but its simplest form may not have an imaginary number within it, in the denominator. So, denominators may not contain any radical expressions or imaginary numbers. Denominators may not contain any radical expressions or imaginary numbers. Which means, how do I get rid of them? You multiply by what you need to eliminate the radical expression or imaginary number. You need to remember that I squared is equal to 1. Whenever I say you need to multiply by what you need, you can only multiply by 1. But how many forms can 1 take on? Infinitely many. 5 divided by 5, 10 divided by 10, x divided by x, I divided by I, square root of x divided by square root of x, negative 15x minus 4 divided by negative 15x minus 4. Those are all 1, right? It's all 1. It's kind of like whenever you guys go to your homecoming or to your prom, you go home and you add stuff to make you appear the way you want your outward appearance to look like, correct? Okay? You're still exactly the same person. So in order to not change something, you can only multiply it by 1 because you want to get it back. Does that make sense? So now, when you look at this, what can you determine? They're all divisible by 3, aren't they? That means 9 divided by 3 is 3. 12 divided by 3 is 4. 3 divided by 3 is 1. So what I actually have is 3 plus 4i divided by I. That's my problem. Do you all see that? That is its simplest form right now, isn't it? But what do you see on the denominator of your simplest form? An imaginary number. Now, I can't have an I there, so I need a numerical value of I. And what is the only numerical value that we know of I? I squared has to equal negative 1. So I have to make this I turn into an I squared. So I need to multiply by 1, but actually, that 1 turns into be what? What I need. I have 1 I currently. I need I squared down there. So what do I multiply I by to get I squared? By 1I. So what I do to the bottom? Do to the top. That's what makes it 1. Does that make sense? So now I put parentheses around the top. And what am I going to do? Distribute 3i plus 4i squared all over I squared. And every place you see an I squared, what do you put in? Negative 1. 3i plus 4 times negative 1 all over negative 1. Do we see that? Now, when you divide by a negative 1, is that the same thing as multiplying by a negative 1? What is 5 divided by negative 1? Negative 5. What is 5 times negative 1? So, is dividing by negative 1 the same thing as multiplying by negative 1? It is. So what I can do is move that negative up top and distribute, correct? Yes or no? So if I distribute that, what's it give me? Do I like the way that's written? 4 minus 3i. That is its simplest form. Because that 3i goes with that minus 4. It cannot leave that minus 4. It has to stay with it. If you cancel out those i's, that's not correct. Because that denominator goes to both the 3i and the 4. You see that? You cannot cancel them out. It's kind of like your head goes with your body everywhere you go. You can't chop off your head and expect you to still walk, right? Okay. Now, let's do it again. Can anything simplify? No. I need a number in the denominator. How can I transform that I to be a numerical number? I need I squared. So times it by 1, which turns out to be what? I over I. Do we all see that? Okay. And I'm now going to distribute 5i minus 2i squared all over 3i squared. Now what? The I squared is equal to negative 1. 5i minus 2 times negative 1. 3 times negative 1. So what's that top become? All over negative 3. Do I like that? No. So how should I rewrite it? All over negative 3. Now if I want it to be an a plus bi form, what I need to do is pull that apart. So how do I pull it apart? 2 over negative 3 plus 5i over negative 3. This is my a, this is my bi now. Do you see that? Do we see that? What? Okay. They are the same thing, but in the back of the book, they're going to give you the a plus bi form at the bottom. Okay? So whenever you're checking your answers, if you don't know if you're right or wrong because your answers are different than theirs, you need to understand why. Okay? Okay, next. Well, what happens when you divide by a complex number? We've added, we've subtracted, we've simplified imaginary numbers, we've multiplied by imaginary numbers, we've divided by imaginary numbers. Now we need to divide by a complex number. It's still exactly the same. You're still multiplying by a value of 1. But the value of 1 changes. Because before I had just an imaginary number. Now I have a complex number. In other words, there's a real and an imaginary part. So how do we get rid of that? When dividing by a complex number, you have to get rid of the complex number. You have to multiply by its conjugate. What's a conjugate? Conjugate is the real number, stays exactly the same, but the imaginary sign changes. I'll give you guys a minute to copy that down. Now, if I have a plus bi, its conjugate, by definition of a conjugate, says that the real number stays exactly the same. So what is exactly the same as a plus bi? What's the real number? A. And then it's the opposite of the imaginary number. So if it was positive, it becomes minus bi. So that's the conjugate of a plus bi. What is the conjugate of negative a minus bi? Positive negative a stays the same. Negative a stays the same. And instead of minus bi, it turns into plus bi. Do we see that, yes or no? That's what a conjugate is. The real number stays exactly the same, And the BI, imaginary number, is the one that changes. Do we get that, yes or no? Okay, so with that said, I need to multiply by a value of 1. I need to eliminate the imaginary number. So what is the conjugate of my denominator? Three minus 4i is my conjugate, right? Conjugate is 3 minus 4i. Yes? So now I'm going to have 5 minus 2i over 3 plus 4i, and I'm going to multiply that by the conjugate, which is 3 minus 4i over 3 minus 4i. The conjugate is going to be the real number stays the same, and it's the opposite sign of the imaginary part. Okay? And now, you FOIL the top, and you FOIL the bottom. 5 times 3 is 15. 5 times negative 4, negative 20i. Inner gives me negative 6i. And last gives me 8i squared. The denominator, 3 times 3 is 9. 3 times negative 4 is negative 12i. Inner is positive 12i. And last is 16i squared. Now, simplify the top. So that's going to be 15. What's negative 20i and negative 6i? Negative 26i plus 8i squared over, what happens to the denominator? The inner and outer cancel out, don't they? And what you have is 9 minus 16i squared. Now, that's important to understand. Why is that important to understand? Because the whole point of multiplying by the conjugate is to get a denominator where there are no i's. Because what's going to happen to those I squareds? Now the I squareds turn into negative 1. Yes? Now I'm showing an awful lot of steps here. You do not need to show me all these steps. You should be able to do a lot of this in your head. 15, this turns into minus 8. What's 15 minus 8? 7 minus 26i over, what is 16 times negative 1? That's going to be turned into a positive 16. So what's 9 plus 16? So now I have this as my answer, okay? What is my a plus bi form? Seven over 25 minus 26i over 25. Rachel? I'll put it in the directions. Okay, now why are we learning about this complex numbers? Why? What's the point? Yesterday we talked about the discriminant, right? The reason why is so that you can find out when the discriminant is less than 0, can you calculate it now? And you can. A is 2, B is negative 3, C is 5. Writing our formula. This gives me a negative times a negative is a positive 3, plus or minus. Negative 3 squared minus 4 times 2 times 5. All over 2 times 2. 3 plus or minus 2 times 4. 2 times 2 is 4. And this is going to be 9 minus 40. And what does that give you? Three plus or minus the square root of negative 31 over 4. Before, could you do that? You couldn't, could you? But now, can we? Sure. Because what is the square root of negative 31? 31 times negative 1, which is what? right? So I can replace that negative 1 with what? I squared. Do you see that? Yes? So that's going to be 3 plus or minus I squared of 31 over 4. That's the whole point of complex numbers and why we need them. Okay? Now, tonight for homework, we have a lot of adding, subtracting, and multiplying. A little bit of dividing. So tonight's homework is 9 through 37 odd, 39 through 44 all, and 49 through 55 odd.